Good morning. Myself, M.DHINESHKUMAR, Assistant Professor in Department of Electronics and Communication Engineering, Adiman College of Engineering in Osor. Today I am going to present the subject name is Communication Theory. Topic is Amplitude, Basic Amplitude Modulation Technique. These are the content of the modulation and amplitude modulation. First we have to discuss about what is modulation. The modulation is the process. Some characteristics of high frequency carrier signal is changed according to the instantaneous amplitude of the information signal. The high frequency carrier signal is nothing but a band pass signal, and the information is a baseband signal, that is depends upon the amplitude or frequency or phase. That is a classifications of three type of modulation. That is a instantaneous amplitude means that is a amplitude modulation. Instantaneous frequency means that is a frequency modulation, or instantaneous phase is of the information is called a phase modulations. These are the basic three modulation techniques: amplitude and frequency and phase modulation. Okay, next we go to why the modulation is important. The first one is reduction in height of antenna. Then second one is avoid mixing of signals. Then third one is increase the range of communication. Then fourth one is multiplexing is possible. That is a more number of signals transmitted in simultaneously. Then fifth one is very important, improves the quality of reception. We have sent the one information and also received the output. It is a improve the quality receptions. About modulation, that is the application. Example for the TV broadcasting. The TV is both the audio and video signal is broadcasting in a single method. So in previous session we have discussed about the multiplexing is possible. So that is a audio and video signals. Then second one is a mobile radio communication. Such as we are using the cell phone. The audio and the video it will be combined and transmit in one point to another point. There are three basic modulation techniques explained. First one is amplitude modulation. That is where firstly that is information. So that is instantaneous amplitude changes means that is amplitude modulation. Instantaneous frequency changes means that is a frequency modulation. There is instantaneous changes in the phase is a phase modulation. There are the three basic modulation techniques in our communication theory. So the amplitude modulation of high carrier signal is varied according to the instantaneous amplitude of modulating signal m of t. So carrier signal is nothing but a cos of 2 pi fct or cos of omega ct. Already we know the 2 pi fc is nothing but a carrier signal, that is omega c. Next modulating signal m of t equal to cos 2 pi f m. M means that is a message signal m of t or cos omega m t. These are combined carrier and modulation signal and produce that is a AM signal. SAM of t equal to, that is a AC is nothing but a carrier signal plus m of t is equal to a message signal, that is a cos for the same. So cos of 2 pi fct is in outer side. Next, how the AM modulation and demodulation process is running. So we have first the baseband signal is nothing but that is a modulating signal. So that is a sinusoidal signal. So we have called a sinusoidal signal. Then it will pass through the modulator section. The modulator section is nothing but here, that is a multiplier. So multiplier means that is adding the carrier signal and the message signal. Then modulator signal, it will be combined the FM signal and FC signals and produce a, that is a band pass signal with frequency FC. So this is a signal of amplitude of the amplitude modulation. Next, we have passed through the signal in demodulator section. The demodulator section, it will be demultiplier. That is remove the unwanted carrier signals. Say only pass to the output of original message signal. This diagram is very clearly explained. Next, the amplitude signal is generated using a multiplier. So multiplier is combined the message signal and the carrier signal. Then all information is carried out by the amplitude of the carrier. The AM carrier signal has a time varying envelope. That is a time varying means that is instantaneously it will be varying the according to the amplitude. Next, the frequency domain AM signal has a two sidebands, lower sideband and upper sideband. So lower sideband is a FC minus FM, and then upper sideband is nothing but a FC plus FM. So FC is nothing but the carrier frequency minus message signal FM. Then upper sideband FC plus FM. These are the additional and the subtractions. These are the how the signal is a amplitude modulator signal is produces. So first one is here that is a amplitude signal, so that is a sinusoidal signal. Next we have adding the carrier signal, that is a FC, that is a carrier signal. So instantaneously changes the corresponding to carrier signal, that is a minimum amplitude, that is a maximum amplitude, that is a envelope of the signals. So these are combining the amplitude of the amplitude modulations. So modulation index of AM signal, that is already we know the M of t is equal to message signal AM cos of 2 pi FM of t. The carrier signal is 2 pi cos 2 pi FC of t. Modulator signal SM is equal to AC carrier plus AM modulator signal cos 2 pi FM of t cos 2 pi FC of t. So AC is a carrier signal, it will be outer side 1 plus K. K is nothing but a modulation index. So modulation index is nothing but the ratio between the modulation signal divided by the carrier signal. So very important is a very important parameter is modulation index. When the modulation index is 0, no modulation occur in the process. When K equal to, that is modulation index equal to 1, 100% modulation is processed. When K equal to 1, that is a over modulation, that is a discontinuous of the original signals, that is losses signal, that is called a losses signal. So in the diagram we have clearly explained the modulation index is 1 means that is a signal, it will be envelope is reached the point 0. When the modulation index is 0 means only no information transmit the signal. When K equal to greater than 1 means the in between gap will be removed, so the loss will be occurred. So we have maintained modulation index K equal to 1. Next we have go for the types of amplitude modulation. The analog modulation type is basically classified in amplitude modulation and angle modulation. So amplitude modulation can be classified into the AM/DSP, SE, AM/DSP, WC, AM/SSP, SE. That is a single suppressed carrier, that is a wideband carrier, SE. That is a single sideband, that is a double sideband. In angle modulation basically classified into two types, that is a frequency modulation and a phase modulation. So double sideband suppressed carrier modulation is nothing but it is a technique used for the transmission of signal that consists of a carrier along with the two sidebands, both the lower sideband and upper sideband. That is called a double sideband suppressed carrier modulation. Then second one is single sideband modulation. That is also a one type of technique which only a single sideband is transmitted through the channel. So that is called a SSB-SC. That is single sideband, means that is only for transmit higher upper sideband or lower sideband. In third one is vestigial sideband modulation. That is a technique modulation involve modulating one sideband and the vestigial portion of the signal. Vestigial portion means that is a half of the sidebands. That is a FC plus FM means that is a OC. That is a half of 1/2 FC plus FM. Next we go for the advantages of amplitude modulation. So first one is amplitude modulation is inexpensive. Then second one is amplitude modulated signals are reflected by the earth from ionosphere layer and allowing them to travel further and cover a large regions. The required carrier frequency is minimal range. It requires the use of basic transmitter and receiver. In audio signal transmission, reception is very simple. Then the use of the circuit with minimal component makes amplitude modulated signal demonstration less difficult. Next, disadvantage of amplitude modulation. That is noise will be compared to the other method is very high and also difficult to receive the signal in receive the signal multiplexing of signal noise. And then audio signal quality is very low. If the amplitude modulated signal is weak, complex configuration is required for the receiver section. That is nothing but a heavy filter section will be needed for the receiver end. In terms of bandwidth utilization, amplitude modulation is less efficient. The modulated signal bandwidth twice of the frequency of the signal wave. Amplitude modulation is similar inefficient in terms of power consumption. It only the sideband power is used. Only one sideband power is used. So application of the amplitude modulation is that is broadcasting of long and medium short wave band. That is used for TV means that is a long range, and also we use it for the very less means that is a local radio example. Many aircraft communication is used for the same amplitude modulation used for the VHF band. In single sideband modulation used for point to point or HF radio communication. It needed for only a smaller bandwidth. Then fourth one is data can be transmitted using quantum amplitude modulation through the short range wireless network like Wi-Fi to cellular telephone, among other methods. Thank you.